Hey, I've been preparing for the 08074 Advanced Computer Programming exam in Guangdong. There's so much ground to cover: Python data types, OOP, algorithms, GUI, databases, networking. Where should we even start?
Great question. Let's start with data types since they're foundational. In Python, the key distinction is between mutable and immutable types. Lists and dicts are mutable, while tuples and strings are not. That affects how they behave when passed into functions.
Right, and immutability is why strings in Python are safe to use as dictionary keys. Tuples too. But I always remind students, just because a tuple is immutable doesn't mean the objects inside it are. If a tuple contains a list, that list can still be mutated.
That's a classic trap. Moving to control structures. The exam loves testing nested loops and the use of break continue and else on loops. Did you know Python's loop else runs only if the loop was not broken out of? That surprises a lot of students.
Yes, it's one of Python's quirky but powerful features. It's super useful for search loops. If you find the item, you break. If not, the else block handles the not found case cleanly without a flag variable.
Let's talk about functions. The exam often tests default arguments and ***. Works. The important thing is that default argument values are evaluated once at definition time, not each call. So using a mutable default like a list is a well-known bug waiting to happen.
Exactly. If you do *def add item lst equals and call it multiple times, you're sharing that same list across all calls. The fix is to use none as the default and create the list inside the function body. This is a very common exam pitfall.
Now OOP. This is a big section. Encapsulation in Python is done by convention, using a single underscore for protected and double underscore for name-mangled private attributes. It's not enforced by the language, but it signals intent to other developers.
And inheritance. Python supports multiple inheritance via the MRO, the method resolution order. Python uses the C3 linearization algorithm to determine which parent class method gets called first, going left to right through the base classes.
Polymorphism in Python is duck typing in practice. If an object has the method you need, it works, regardless of its class. That's why you see things like both lists and custom iterators working seamlessly in a for loop.
Special methods are also heavily tested. *__init___ is the constructor. *__str___ is for human readable output. *__repr___ is for developer facing representation. And *__len __getItem let you make custom objects behave like sequences.
Let's shift to algorithms and data structures. The exam covers list comprehensions, dictionary comprehensions, and set operations. A comprehension like x times *2 for x in range 10, if x%2 == 0 is both concise and efficient. It avoids the overhead of repeated list.append calls.
Recursion is another key topic. The classic examples are factorial and Fibonacci, but the exam might ask about recursive directory traversal, or tree traversal. Always remember Python has a default recursion limit of 1000. For deep recursion, you'd need to increase it or use iteration.
For sorting, students should understand that Python's built-in *sort uses timsort, a hybrid of merge sort and insertion sort, stable and log(n) in the average case. The !key equals !parameter lets you sort by custom criteria without altering the data.
Binary search is also tested. It requires a sorted list and halves the search space each step. The bisect module implements this neatly. Students should understand why it's log(n). Each comparison eliminates half the remaining candidates.
Exception handling is crucial. The try except else finally structure is important. The else block runs only if no exception was raised, and finally always runs, even if there's a return in the try block. That makes finally perfect for cleanup, like closing files.
And you can raise custom exceptions by subclassing exception. That's good design. It lets callers catch your specific error type separately from generic errors. The exam might ask you to define a custom exception and raise it with a meaningful message.
File I/O. The safe pattern is using backquote with open file name as f backquote, which is a context manager. It ensures the file is properly closed even if an error occurs inside. Reading line by line with backquote for line in f backquote is memory efficient for large files.
For serialization, JSON is human readable and cross-platform. Use backquote JSON.dumps, backquote to serialize, and backquote JSON.loads, backquote to deserialize. Pickle is Python specific and can serialize almost any Python object, but it's not safe to unpickle untrusted data.
The backquote OS backquote and backquote SYS backquote modules come up a lot. Backquote OS path.join. Backquote builds paths in a platform-independent way. Backquote OS.listdir backquote lists directory contents, and backquote OS makeadirs backquote creates nested directories. Backquote SYS. ARGV backquote gives command line arguments, and backquote SYS.exit backquote terminates the program.
The datetime module is also tested. You create a date with backquote datetime.date, year, month, day, backquote, and arithmetic like subtracting two dates gives a backquote time delta backquote object. Formatting with backquote strftime backquote and parsing with backquote strftime backquote are practical skills the exam loves.
Now GUI with tkinter. The core concept is the event loop. You create widgets like backquote label backquote, backquote button backquote, backquote entry backquote, pack or grid them into the window, bind callbacks to events, and then call backquote main loop, backquote which blocks and processes events until the window closes.
The geometry managers are important. Backquote pack, backquote stacks widgets linearly, backquote grid backquote places them in rows and columns, and backquote place backquote uses absolute coordinates. For exams, grid is the most flexible for forms and layouts. You can span across multiple columns.
Database with SQLite 3. You connect with backquote SQLite3.connect, backquote get a cursor, execute SQL statements, and commit changes. The key workflow is connect, cursor, execute, commit, close. Parameterized queries with backquote, backquote, placeholders prevent SQL injection.
And fetching, backquote fetchOwn, backquote returns one row, backquote fetchAll, backquote returns all rows as a list of tuples. Creating tables with backquote create table, if not exists backquote, is a good practice that avoids errors on repeated runs. This comes up in practical coding questions.
Network programming. The socket module is the foundation. You create a TCP server by binding a socket to an address and port, listening for connections, then accept machine each client in a loop. The client connects, sends data, and receives a response.
The backquote requests backquote library simplifies HTTP backquote requests.get URL. Backquote fetches a page, and backquote JSON backquote on the response parses JSON automatically. For the exam, knowing how to handle response status codes and parse JSON responses is sufficient.
Functional programming. Lambda creates anonymous functions inline. Backquote map, func, iterable. Backquote applies a function to every element. Backquote filter, func, iterable. Backquote keeps only elements where the function returns true. These are clean alternatives to explicit for loops.
Decorators are elegant but intimidating for many students. A decorator is just a function that takes another function as input and returns a new function. It wraps the original to add behavior, like logging or timing, without modifying the original code.
Generators are memory-efficient iterators. A generator function uses backquote yield backquote instead of backquote return backquote. Each call to backquote next, backquote resumes execution from where it left off. This is ideal for processing large data sets without loading everything into memory at once.
Context managers via backquote underscore underscore enter underscore underscore backquote and backquote underscore underscore exit underscore underscore backquote are how backquote with backquote statements work. You can write your own context manager so that setup happens in backquote underscore underscore enter underscore underscore backquote and teardown. like closing a database connection, happens automatically in exit backquote.
For multi-threading, the threading module lets you run tasks concurrently, but Python's GIL, the global interpreter lock, means only one thread executes Python bytecode at a time. Threading is great for I/O-bound tasks, but not for CPU-bound computation.
For CPU-bound work, multiprocessing is the answer. Each process has its own memory space and GIL, so they truly run in parallel on multiple cores. The exam may ask you to distinguish when to use threading versus multiprocessing.
To wrap up, the exam structure tests both theory, like explaining what a decorator or generator does, and practical coding. My advice: write actual code for every concept, not just read about it. Hands-on practice is the only way to internalize these patterns.
Absolutely. And review the standard library thoroughly. OS, SYS, datetime, random, JSON, SQLite 3, threading. These appear in almost every practical question. Knowing how to combine them in a single program is what separates a pass from a high score. Let's go deeper on decorators, since students often memorize the syntax without understanding the mechanics. At its core, a decorator replaces a function with a wrapper. When you write at my_decorator above a function, Python immediately calls my_decorator, original_func, and binds the result back to the same name.
Right, and that's why the wrapper function must accept the same arguments as the original, or use args and *wargs to be generic. If you forget to return the wrapper's result, the decorated function will silently return none, which is a subtle and frustrating bug.
There's also the issue of losing the original function's metadata. After decoration, func__name__ shows the wrapper's name, not the original. The fix is applying at functools.wraps, func, inside your decorator. It copies the original's name, docstring, and signature onto the wrapper.
Stacking decorators is another exam topic. When you stack at decorator_A and at decorator_B, Python applies them bottom up. Decorator_B wraps first, then decorator_A wraps the result. The execution order when calling the function is top-down though, so at decorator_A's wrapper runs first.
Now generators. Let's be precise about how yield works internally. When a generator function is called, it doesn't execute at all. It returns a generator object. Execution only begins when you call next on that object, and it pauses at each yield, preserving the entire local state.
That state preservation is what makes generators powerful. Local variables, the instruction pointer, even the call stack, all frozen between yields. A generator that reads a huge log file line by line uses only a tiny amount of memory versus loading the entire file into a list.
Generator expressions are also testable. They look like list comprehensions, but with parentheses instead of brackets. Like $xts*2 for x in range 1000, . They're lazy. They compute each value on demand, unlike list comprehensions which compute all values up front and store them.
You can also send values into a generator using the send method. The yielded expression can receive the sent value, making generators two-way communication channels. This is the foundation of coroutines, though for this exam, understanding basic yield behavior is the priority.
Let's talk about iterators more precisely. An iterator is any object with both __iter__, and __next__ methods. __iter, __return self, and __next, returns the next value or raises stop iteration. A for loop automatically calls these. It calls iter on the iterable, then next, repeatedly.
That's why you can iterate over your custom class. Just implement __, iter, __, returning self, and __, next, __, with your logic. Once stop iteration is raised, the for loop exits cleanly. This is cleaner than index-based loops for custom data structures like linked lists or trees.
Context managers. Students should be able to write one both ways, using a class with __, enter underscore underscore and underscore underscore exit underscore underscore, and using the @context manager decorator from ContextLib. The decorator approach is elegant. Everything before yield is set up, yield is the body of the with block, and everything after yield is tear down.
The underscore underscore exit underscore underscore method receives 3 arguments: xc underscore type, xc underscore val, and xc underscore tb. These describe any exception that occurred inside the with block. If underscore underscore exit underscore underscore returns true, the exception is suppressed. Returning none or false lets it propagate. This gives you fine-grained control over error handling.
Now let's drill into multi-threading for the exam. The threading.thread class takes a target function and optional args. You call .start to begin execution and .join to wait for it to finish. Without join, your main program might exit before threads complete their work.
Race conditions are the main hazard. If 2 threads modify a shared variable simultaneously, the result is unpredictable. The fix is a threading.lock. One thread acquires the lock, does its work, then releases it. The other thread blocks until the lock is available.
The with statement works beautifully with locks. With lock. Acquires on entry and releases on exit, even if an exception occurs inside. This is much safer than manually calling lock.acquire and lock.release, where you might forget the release and error paths.
For the multiprocessing module, the interface mirrors threading almost exactly, but each process runs in its own Python interpreter with its own memory. Sharing data between processes requires explicit mechanisms like queue or pipe. You can't just share a variable like you can with threads.
Let's revisit tkinter with more depth. The string var, int var, and double var are special variable types that auto-notify widgets when their value changes. Bind a string var to an entry widget's text variable option, and reading its .get gives you the current input without manual event handling.
Message boxes are practical exam material. !messagebox.showinfo, !messagebox.showerer, and !messagebox.asciiasno, create pop-up dialogues. The asciiasno variant returns true or false, so you can use it for confirmation dialogues before destructive operations like deleting records.
The Canvas widget is worth knowing. It lets you draw shapes, lines, text, and even images programmatically. You call !canvas.create_rectangle, !canvas.create_oval, and so on with coordinate arguments. It's useful for simple data visualization or game boards in exam coding questions.
For event binding in tkinter, the bind method maps events to callbacks. The event string format is important. Less than button -1, greater than, is a left click. Less than key press return greater than, is the enter key. Less than motion greater than, tracks mouse movement. The callback receives an event object with X, Y coordinates, and more.
Now let's go deep on SQLite 3. Transactions are key. By default, SQLite 3 in Python operates in auto-commit mode for DDL, but requires explicit commit for DML, like insert, update, delete. Forgetting to commit is the most common mistake students make in coding questions.
Using a connection as a context manager with SQLite3.connect, as con, handles commit and rollback automatically. It commits on clean exit and rolls back if an exception occurs. This is the safest pattern and shows good understanding of transactions in exam answers.
Row objects versus tuples. By default, fetchAll returns tuples. But if you set con.row_factory equals SQLite3.row, you get row objects that support both index and column name access. So row name works instead of row 0 much more readable in larger queries.
For network programming with sockets, the distinction between TCP and UDP is testable. TCP uses sock_stream. It's connection-oriented, reliable, and ordered. UDP uses sock_DGRAM. It's connectionless and faster but has no delivery guarantee. Most exam questions focus on TCP.
The TCP server workflow has a specific sequence. Socket creates the socket, bind, assigns the address and port, listen, puts it in listening mode, then accept, blocks until a client connects, and returns a new socket for that specific client, plus the client's address.
On the client side, socket creates it, then connect, initiates the handshake to the server's address and port, then send, and RECV, exchange data. The RECV argument is the buffer size, typically 1024 or 4096 bytes. Always decode bytes to string, with .decode, UTF-8.
A common exam question asks you to write an echo server. The server receives a message and sends it back unchanged. It tests whether you understand the full socket lifecycle, including closing the client socket after the exchange and the server socket when done.
The requests library abstracts all of that for HTTP. One thing worth noting, always check _response.status _code before processing the body. A 200 means success, 404 means not found, 500 means server error. The shortcut _response.raise for _status, throws an exception for any 4XX or 5XX code.
Let's revisit exception handling edge cases. You can catch multiple exception types in one except clause using a tuple, except, value error, type error, as E, The as E binds the exception instance, so you can print STRE to show the error message in your output.
Exception chaining is advanced but may appear when you catch one exception and raise another, Python automatically chains them. You can also use raise new exception from original _exception to explicitly set the cause, which shows up clearly in tracebacks.
For modules and packages, students should know that a package is simply a directory with an _init_.py file. When you import a package, Python runs _init_.py. You can put import statements there to make submodule contents available at the package level. That's why you can do from my package import my class instead of the full path.
The if __name equals _main_main_main__ guard is essential for reusable modules. When a file is run directly, __name__ is __main__. When it's imported, __name__ is the module's file name. The guard prevents test code or demo runs from executing when the module is imported by another script.
The random module is frequently tested in practical questions. Random.randint, AB, returns an integer, including both endpoints. Random.choice, SEQ, picks one element from a sequence. Random.shuffle, LST, shuffles a list in place. Random.sample, population K, returns K unique elements, without modifying the original.
For the datetime module, computing the difference between two dates is a practical skill. Subtracting two date objects gives a time delta, and .days gives the number of days between them. Adding time delta days equals 30 to a date gives you a date 30 days later, useful for deadline calculations.
Let's talk about comprehensions more broadly. A dictionary comprehension like KV for K, V in items if V greater than 0, both filters and transforms in one expression. A set comprehension with curly braces automatically deduplicates. These are not just syntactic sugar. They're often faster than equivalent loop code.
Nested comprehensions deserve attention too. 0 calls for _ in range, rows. Creates a 2D matrix correctly. Each row is a separate list. The naive eticals looks similar, but creates rows that are all the same object, so modifying one row modifies all of them.
That's a great exam trap. Let me add one more. Shallow copy versus deep copy. List 2 equals list 1. Or list. List 1. Creates a shallow copy. The outer list is new, but nested objects are still shared. Copy.deep copy, list 1. Recursively copies everything, so nested lists are fully independent.
For the final stretch of exam prep, pickling. Pickle.dump, obj, file, serializes to a binary file, pickle.load file, deserializes. It can handle almost any Python object, including custom class instances, but never unpickle data from untrusted sources. It can execute arbitrary code during deserialization.
JSON serialization is safer and more portable. The only limitation is that JSON supports only basic types: strings, numbers, lists, dicts, booleans, and none. If you need to serialize a custom object, you must write a custom encoder by subclassing JSON, JS-only-encoder, and overriding its default method.
All right, let me give a high-level exam strategy. Know your data types cold. Be able to write a class with inheritance, overriding __str, __, and at least one other special method. Be able to write a generator, a decorator, and a context manager from scratch without looking anything up.
And for practical coding sections, always handle exceptions around file and database operations, always close resources with statements, and always test your output mentally. Trace through the code line by line before writing your final answer. Those habits separate good scores from great ones.
One last thing. The OSWalk function is extremely useful and often appears in file system questions. It yields a 3-tuple of dir path, dir names, and file names for every directory in a tree. You can recurse an entire folder structure in just 3 lines of code using a for loop over os.walk.
Perfect note to end on. The exam rewards students who can read a problem, identify the right module and pattern, and write clean, correct code efficiently. Master the standard library, understand how Python's object model really works, and you'll do very well on 08074. Good luck, everyone.